All right, so this is worth memorizing. The biased techniques are convenience and self-selected. Stratified, cluster, and simple random all reduce bias. Okay, so memorize that because I can change these questions up any way I want to. So are biased is the real question, is convenience and self-selected. Those are the biased ones, and it is multiple select. All right, a class of students is randomly divided into two groups. One group meditates before taking a test, the other group does not. This has all the elements of an experiment. You can tell that a variable has been introduced. That is dead giveaway to being an experiment. Whether it be a controlled experiment or not, it is an experiment. It's not necessarily a controlled experiment because we didn't assign things randomly, but it's definitely an experiment. All right, part A, a data set is normally distributed with a mean of 20 and a standard deviation of 0.5. Find the z-score. So you need to know a formula for a z-score. Z is simply x minus x bar sitting over sigma standard deviation. So I want a z-score for this data. It's going to be data value of 25, 20.5 minus the mean, which is 20, over the standard deviation of 0.5. That's going to give me 0.5 over 0.5, which is 1. Z is 1. Easy peasy. Most kids could do a z-score the other day. Working with them was a little uglier. But whatever. In part A, about what percent of the data is between 19.8 and 20.2? So this is kind of weird when you think about your bell curve, and that's what this is all about. But the mean is at 20. And if we add one, we're at 20.5, and take away one, we're at 19.5. So think about your empirical rule, your bell curve, your 95, 99, your 68, 95, 99.7 rule. It says that these two regions of space account for 68%. They're each 34, okay? Now, 19.8 would be about right here, and 20.2 would be about right here. It doesn't take a leap of faith to realize that it's close to 34%. But most of you are not going to visualize, you're not going to draw. Several of you miss days and you don't even bother to look things up because you could care less, to be quite honest with you. If you can't understand how I came up with the 31, you can use a calculator. You can go to normal CDF. Now, normal CDF, if you remember right, has a lower thing, an upper thing, a mean, and a standard deviation. Those are its inputs. Well, we're going to do it with a lower boundary of the low score, which is 19.8, and an upper boundary of 20.2. And I never showed you how to do this the other day, but it doesn't matter. Mean is given in text as 20, standard deviation is 0.5. So a normal CDF is going to be under second vars 2. And you just type in all the information in the text. 19.8, upper is 20.2, the mean is 20, standard deviation is 0.5. And you scroll down, you hit that paste key, you press the enter key, and it tells you 0.3108, which is about 31%. All right, use the data sets. Choose the words to describe each of the data sets. So what we're going to do here is we're going to put each data set into list 1, and we're just going to do it for each data set. So enter the data into list 1, and then you're going to get stat calc 1 var stats, and you are after the mean, which is your x bar, and your median. And you're also going to want to look at the stat plot. So you need to turn stat plots on. That's going to be second y equal, and specifically the histogram. Okay. Now, there's a couple of things that you need to know that are worth memorizing because I can always create questions around these things too. But for left skewed data, the mean is left, which means less of the median. A left skewed data look like that, okay? You have the tail on the left. For normal, and I want to say approximately, we have a typical bell curve look, okay? The mean is really close to the median. And then we have the right skewed. On a right skewed data, we have a tail on the right. And the mean is right of, which means more than the median. Probably need to turn on your subtitles here. But that's how we're going to look at this, okay? We're going to take in a combination of everything because I don't want to just rely on what the mean and median are. I want to also rely on the histogram. All right, so stat, edit. I'm going to look at data list A to begin with. And this is going to be missed by so many of y'all. Like, it's just ridiculous. I realize that the year's almost over and you're done with it. You can be done with it this summer in summer school as far as I'm concerned. You guys will take notes, but you're not actually taking them. You're just blind. You're on autopilot. I really don't know why I'm sitting here making this twin. Anyway, stat, calc, one variable statistics. Don't have a frequency list to calculate. So it told me that X bar was about 2.91. And if I just scroll down, it'll tell me the median is 3. And what I notice is these are pretty close. They are. They're pretty darn close. So I want to see what the histogram looks like. So second y equals, mine's on already. Make sure you choose the histogram right there. And you're going to press enter. And then zoom 9. Zoom stat. And that's a pretty good histogram. Like, that's pretty close to normal. So I would say that this one, even though the mean is less than the median, I would call it normal. That's what I would call it. Or bell curved. Or I think your book used the word symmetrical. All right, data set B is up next. So stat, edit, clear out. There's going to be at least like 10 of you guys that try to put this one in list 1 and the other one in list 2. Like, I already know what you're going to do. Be glad that breathing is an autonomous function. All right, stat, calc, 1 bar, stats, calculate. So X bar is about 4.27 and the median is 5, which some kids would say they're pretty close. I guess they kind of are. But let's look at the histogram. So I've already turned everything on. It's a zoom 9 situation. And I would not call that normal. I see a tail on the left. So the histogram says left tail. Like, it's apparent that it has a left tail. So I would call this skewed left. That is a skewed left situation. All right, what are the best measure and center of spread to use to describe the data set B in part A? So since the data is skewed left, we use the median and quartiles. They're not saying this. What you're supposed to do is you're supposed to use the IQR, which is the interquartile range. But they want measure of center and spread. So the best one they have listed is median and quartiles. So use the IQR, which is called the interquartile range. Part C deals with data set A. And I decided, I don't know about no we, but I decided the data was approximately symmetrical. And it was pretty darn close to it. So we use the mean and standard deviation, which is choice C. There you go. Moving forward with our lives. Mean on a statewide geography test was 80 with a standard deviation of 12. West County sampled the scores of some of its students, reported a mean of 77 with a margin of error to the nearest whole number. How many students were in West County's sample? Now, they don't say what the level of confidence is, but your book, and that's the thing, this is from your book. Your book only does 95% confidence intervals. That's all it does, 95% confidence intervals. So your book has a formula for margin of error. It is plus or minus 2 sigma over root n, and you have to memorize this. I am not giving it to you. It has to be memorized, so you have to memorize it. So anyways, the margin of error is 1.7, and it will equal plus or minus, and I don't actually need a plus or minus here. It's going to equal 2 sigma, so 2 times 1.7 over the root of n, which is unknown. Here I am just being an idiot. I'm going to multiply both sides by root n because the opposite of division is multiplication. Root n times 1.7 equals 2 times 1.7 should be 3.4. And then I'm going to divide. Wow, this is a small sample, isn't it? Like, this is a teeny tiny sample. Almost makes me think I did something wrong, but I didn't. So I divide both sides by 1.7, and I get that root n is, that's just crazy. Two, so n is going to be 2 squared, which is 4. I just felt so wrong that it turned out to be that small. They sampled 4 kids. All right, so what is a reasonable means of West County sample? What we do is we do the mean plus or minus the margin of error. So 80 minus 1.7 is on the left, which is 78.3, and 80 plus 1.3 is on the right, which is 81.3. Nope, I completely screwed this problem up, didn't I, kids? I knew something was wrong. Where did that 1.7 come from? Right there. I knew something was wrong. Knew it. I'm sorry I just wasted a moment of your life. But I knew something was wrong. Margin of error is 2 sigma. It's right there. I had a different number in my head over root n. Where did I even come up? That's where I saw it. That's margin of error. And it's 1.7. Okay, this is going to look a lot better. Still going to root n both sides. Root n times 1.7 equals 2 times 12, which is 24. Divide out the 1.7. Now we're cooking. Take 24. divide it by 1.7, and we get that decimal, 14.118. I won't use that. N is about 14.118. And the opposite of square rooting is to square. I'll just take my entire decimal and square it. So 199 kids. N is about 199 children. And say to the nearest whole. We would actually say 200, but whatever. 199 kids. It is a really bad looking 199. All right, what is a reasonable range, reasonable means? What is the range of means for West County sample? That's going to be 80 minus the 1.7. This part I was doing right. To 80 plus 1.7. So 80 minus 1.7 is 78.3 and 81.7 when you add. All right, moving forward to some stuff I came up with. The height in inches of 8 high school girls and their scores on an IQ test is given below, as though height of a female has anything to do with her intelligence quotient, but who knows. We're going to put this stuff in our calculator under list 1 and list 2. We're going to read all the instructions that perform a linear regression, not whatever you feel like doing. But height is X, so whoever came up with this data thinks that there is a relationship between height and intelligence. I promise you there is not. The two are not related. Not that I have ever noticed. It seems absolutely silly to do this, doesn't it? This is actually going to be the last one I do because I still have to get ready for 5th period. I've noticed that when I break things up into different videos, the viewership goes down. Now, I'm going to turn something on because you have to have it. I'm going to turn on R. So you go to second 0. You scroll on down for a while to diagnostics on, and Milbrath will have reset your calculator, so it's not going to be on. You're going to have to know how to do this. We're not going to play the come up to Milbrath and ask them how to do stuff. Like, I'm tired of that. I am spending the time, and you obviously are not. Diagnostics is on. The reason I'm doing that is because part 2 asks for R. So stat calc, it says do a linear regression, not whatever you feel like. That's line reg. There is no frequency list. We're not even going to bother with storing the regression equation. Sound like Carter there for a second. And here we go. There's my equation. So my equation is y equals 0.1316x plus 102.0735. It says find and interpret R. So R is given as 0.0509, or let's say 10. And I'm supposed to interpret this. Okay, so a strong R is where the absolute value is stuck between 0.8 and 1. A moderate R is when we are stuck between 0.3 and 0.8, but not inclusive. And a weak R is when we're stuck between 0 and 0.3. So this is definitely, and I'm going to introduce a very, this is a very weak linear correlation. It's not just that it's a weak correlation, it's a weak linear, because R is for lines, weak linear correlation. And it is positive. There's a weak positive linear correlation. All right, I need to stop so I can get ready for fifth. So I've only got just a little bit left to do. I got most of it. Till next time.